Hello everybody, this is Mr. Kusaj. These are the notes for chapter 4-7, the law of sines and the law of cosines. If you were looking for 4-6, they don't exist because we're skipping them. So 4-7 is a lot of algebra involved, solving equations. So some of you might find that easier. Okay, let's begin. What we want to do now is solve oblique triangles. Oblique means non-right. If it's not a right triangle, then we refer to it as an oblique triangle. So how do we solve those? Okay, we have a lot of experience with right triangles. We can do all sorts of things with right triangles using sine, cosine, and tangent, SOHCAHTOA, and all that. But what if it's not a right triangle? Well, there are two rules called law of sines and law of cosines that can help us. First of all, let's look at the notation. Traditionally, in a triangle, we always use three capital letters for the angles, and then immediately opposite the angles, we use the same letter but lowercase. You notice that? It always works like that. So if I'm looking for side A, I know it's opposite angle A. If I'm looking at angle C, I know it's opposite side C. Okay, they always go in pairs like that. So let's look at the law of sines first. The law of sines is really a proportion. Sine of A, angle, right? Sine of A over little a is equal to sine of B over little b. And it's equal to sine over C over little c. Now, you wouldn't use all three of them at the same time, but you could use any two, right? You could use those two, or those two. Which two would you use? Well, it all depends on the situation. You can use any two of them that you want. Okay, one thing you need to know about the law of sines is, you might freeze here and just copy first and then listen to me. Okay. One thing you need to know about the law of sines is it can only be used if the given information includes any angle and a side opposite it, right? You got to have an angle and a side opposite. That's what I'm saying here. You use it if you have an angle and opposite side. Well, here's an example, and notice I do have an angle and a side opposite. So I can use the law of sines here, okay? But first, since we want to find all the parts, let's get the angle out of the way because that's the easiest, right? Angle C is obviously 180 minus these two angles. I'll be left with angle C. So using the 180 rule, I find out really quickly angle C is 42. So I did angle C. Now I need to find these two sides. Well, I'm going to use this angle and this side, so I'm going to need side B over B, right? That's sine 103 over 20. And then if I want to find sine A, it'll be sine 35 over missing side A, right? A. Sine A is sine 35 and the missing little a. Now what you have is a straightforward proportion, right? Remember, these are just numbers. You can just put those in the calculators. So you have three values, three numbers, and an unknown. That's a proportion. You cross multiply and solve it. We can go over it tomorrow if you've forgotten how to do that, but that's all you're doing is cross multiplying and solving. So we get side A really quick as 11.8. Now to get the other side, the other missing side, C, we do the same thing all over again, but this time we use C in it. So let's use angle B and side B again. Sine 103 over 20, that's this. And now I need to use C. Sine C over little c. Well, we just did C up here. It's 42. So I write down sine 42 over unknown C. And there you go. Very simple again. It's a proportion, right? Cross multiply, and you get C equals 13.7. Okay? So this is, in my opinion, pretty easy. Just plug in the numbers and cross multiply. The only thing you have to worry about is copying the numbers in the right position. So just remember, it's sine of an angle over the side opposite it. It always goes like that. Angle, opposite side. Angle, opposite side. Angle, opposite side. And you just take what you need and solve it. Okay, that's the law of sines. Just one example, but we'll do some more tomorrow. Let's get to the law of cosines. Right there. A little. Okay. Now, the law of cosines is a little harder to memorize. The law of sines looks a little bit like the Pythagorean theorem in the beginning, then it's minus all this multiplication in the end. But there is a pattern to it. So these are the sides, right, because they're lowercase, and these are the sides, and you end with cosine of an angle, which is why they call it the law of cosines, because it involves the cosine. So it says a squared is equal to b squared plus c squared minus 2 times bc times cosine of angle A. So this is all multiplication here, right? Now, if you don't have side A, then you can just switch the letters and start with B, right? B squared is equal to the other two sides squared and added minus 2 times those two sides cosine B, etc., right? So you start with any side you have, and then the other two sides are also, let me put my hand over here, and then the other two sides are squared, and then it's minus 2 times these same sides but multiplied, and then cosine, capital letter of what it was in the beginning. Did you notice that? So there is a pattern and you can memorize it. The important thing to remember for the law of cosines is that you use this law when you can't use the sine, because the sine is way more simple to use. But what if we don't have an angle and opposite side? Excuse me. Look at this situation, right? I have side, and an angle in between. I do not have an angle and an opposite side. I don't. Look carefully. Same thing here. I don't have an angle. In fact, I don't have any angles. I have 3 sides. Okay? So when you don't have an angle and opposite side and you can't use the law of sines, then you're forced to use the law of cosines. Okay, let's look at an example. Okay, so if notice in this example right away that we can't use law of sines, because if you try to use the law of sines, look what happens. Sine of 65 over c is equal to sine of b over 8. You have 2 unknowns, so it doesn't work here. The law of sines, if you try it, you'll see that you'll run into trouble. So notice that we have angle C, right? We have information about angle C. So I have this angle, so I'm going to start the whole formula with C. In other words, I'm going to pick the one that starts with C. They're the same, but to match my situation, I'm going to start it with C. So C squared is equal to the other two sides squared, right? The other two sides squared and added minus 2 times the other two sides multiplied, 8, 5, times cosine of the angle that we have. There you go, right? The two sides that we have squared, the two sides that we have multiplied, ended with cosine of the angle that we have. So order of operation tells us that we do the powers first, and then the multiplication, and then we do the plus and minus. Okay, so all I'm doing is just straightforward algebra here. I'm solving for C. So this comes out to 55.2. C squared is equal to 55.2. Square root both sides. Ta-da! C is equal to 7.4. I found side C. I already have the other two sides. So I'm done with the sides. right? Now, let's find the angles. Well, I already have angle C, so which should we do first? Angle A or angle B? It doesn't matter. Now, we can use, let me lower it right here first. We can use the law of sines. Why can we use it now and not before? Because now that we know what C is, now we have an angle and opposite side. So I'm going to use this in sine because it's way easier to solve. So notice I start with sine 65 over 7.4, right? Sine of this over this equals sine of A over 5. So I guess I'm going to go find angle A first. Sine of A over 5, right? Now we've done this before. Cross multiply and solve. And you get sine of A equals all of this. You put that on the calculator. This times this divided by this. And you get 0.6124. Now remember when we're looking for angle, we do inverse. Remember that little minus 1? So, excuse me again. It's inverse sine of 0.6124 equals, and you're going to get 38 in the calculator. Done. I found angle A using the sine law. So, whenever you get a problem, you look to see if you have a pair of angle and opposite. If you don't, you use the cosine, and then you only use that once, and then you'll have enough information to use the sine law. Okay? Now, I've gotten what? What did I get? I have little c, I have the other two sides, so I have all three sides. I have angle A and angle C. I just need angle B. Should I use this line of the law of sines? I could, but why bother? You got to think. If you have two angles, if you know two angles, then you can get the third one very easily with the 180 rule. So angle B, the last part that we're looking for, is simply 180 minus the two angles that we have. And there's the third and missing angle. And now we found all the parts. Okay? So, one more time, a little summary. We use law of sines and law of cosines for triangles that are not right triangles. There's the law of sines. It only works when you have an angle and opposite side. Here's an example. You set it up. It involves cross multiplying and solving. Ask more questions tomorrow about that if you're not sure about that. Then the next page we talked about law of cosines. It looks like three different ones, but it's actually the same exact one depending on which information is given to you from the start. And and the important thing is here is you use the cosine law when you don't have an angle and opposite side, one of these situations. So notice here, I start with the C because they give me information about angle C. And I find little c to be 7.4. Then when I have one side, I have enough to use the sine rule. I use the sine rule to get an angle. And then I use the 180 rule to find the missing third angle. I will start off the class tomorrow with two examples, one of each. And you can work on those and we'll take it from there. All right. See you tomorrow. Good night.